In this video, I want to start looking at some basic ways to solve equations. To start with, what does it mean to solve an equation? What are the solutions of an equation? Some equations are true, like 3 plus 2 equal to 5 or 10 equal to 2 times 5. Some equations are false, like 1 equal to 0 or 3 plus 2 equal to 6. Most equations with variables are true for some values of the variable and false for others. As an example, if I have 3 plus x equal to 5, this is true if x is equal to 2, and false otherwise. To solve an equation that has variables in it, we want to determine the values of the variable that make the equation true. And the values for the variables that make the equation true are called the solutions. As an example, if I want to solve the equation 3x equal to 12, it means to find all the values for x for which 3 times x is equal to 12. Well, we know that only 3 times 4 is equal to 12. 3 times any number other than 4 is not equal to 12. So there is one solution, x equal to 4. And even young children in elementary school learn to solve very simple equations. First or second graders could be asked to solve an equation such as 5 plus blank equal to 7. And one source of difficulty in solving these equations is, once again, understanding the equal sign does not mean calculate the answer. As an example, the equation 5 plus 3 equal to blank plus 2. To make this true, many students will fill the box with the number 8 because 5 plus 3 is equal to 8. They are reading the equal sign as meaning to calculate. In order to understand how to solve equations, we have to understand that we want to make the expression on the left and on the right sides of the equal sign the same. And so one piece of helpful imagery for this is equations with a pan balance. If we view this equation in terms of a pan balance, each side of the equation corresponds to a side of the pan balance. To solve it, we need to make the pans balance rather than tilt to one side or the other. So here I have my pan balance. On the left-hand side, I have 5 blocks and 3 blocks since we're adding them together. On the right-hand side, I don't know what this block is, but I know this one's 2. So the question is, how many blocks do I need to replace this question mark, this mystery balance with, to make this pan actually balance? And a pan balance is a wonderful piece of imagery, but it doesn't work well for some equations, such as those involving negative numbers. However, the strategy used here by taking a pan balance view of equations works in general for all equations. So I want to look at solving one of these pan balance problems in addition to solving it the traditional algebraic way. Here I have the equation 4x plus 2 plus x equal to 5 plus 3x plus 3. On my pan balance, I have 4 x's, 2 1s, and an x on the left-hand side. The right-hand side has 5 1s, 3 x's, and 3 3s. There are 3 1s. The first step in the equation might be to combine like terms, to change it to something equivalent. Over here I have 4x and another x, that means I have 5 x's total, plus 2. Over here I have a 3x, and 5 plus 3 is equal to 8. On the pan balance, it's the equivalent of just kind of shifting the x's together and shifting the 1s together on each side. So nothing's really changed on the pan balance. We've just kind of reorganized. We then might want to take away 2 from each side. In equations, that would be a 5x on the left. On the right, 3x plus 6. On my pan balance, that would be the equivalent of removing 2 of the 1s from each side. The next thing we might want to do in our equation is to subtract 3x from both sides. On the left-hand side, 5x minus 3x is 2x. On the right-hand side, we would have 6. In my pan balance, that would be the equivalent of removing 3 of the x blocks from each side. The final step would be to divide both sides by 2. If I do that, 2x divided by 2 is x, and 6 divided by 2 is 3. On my pan balance, that would be equivalent to taking half of each side. So divide each side by 2. I took half of this side to get 1x, half of this side to get 3 1s. So we have x equal to 3. So these pan balances can be a very helpful tool to help us visualize what we're doing in the equation.